So we're going to spend today doing something that you probably learned in, I don't know, 6th grade. How to add fractions, 5th grade. So long ago. But we're gonna look at the mathematical theory behind adding fractions because we're about to add polynomial fractions. Yeah, and it's fun. So polynomial fractions, which is actually called rational functions. So all fractions that have integer coefficients, well, I mean integer in the numerator and the denominator, those are called rational numbers. So we're going to look at rational polynomials where the numerator is a polynomial and the denominator is a polynomial. But, I mean, it's not technically a polynomial because if you have variables and the denominator, it's not. So we call them rational functions. So if we looked at, let's say, something super easy, 1/2 plus 1/3. How do we add these together other than use your calculator? We need a common denominator. How come? I mean, can you give me a reason why you need a common denominator? That's just what somebody told you. So, let's do So, if I have half a pizza and you have a third of a pizza and you take those two and combine them, you have 2 pieces of pizza, right? So I went to Domino's over the weekend, and the guy forgot to cut the pizza, so we get in the van, and my wife opens it up, and I took it back to him. I'm like, you know, I only wanted to eat 1 piece of pizza, but that one is a little too big. So then... So what does it mean to get a common denominator? So I mean, contextually, so if we're going to times this by 3/3, and we're going to times this by 2/2, and that gives me 3/6 plus 2/6 is 5/6. Why is that necessary? Okay, they need to be the same. Why? Say it. Wait, listen to Zach. Zach has something to say. What? Fine. Travis? I don't know. Well, these pieces are different sizes. So, if you consider that 1 piece of pizza and this 1 piece of pizza, sure, I have 2 pieces of pizza, but if you just say you have 1 piece, you have no idea the size of that particular piece. So we're going to break these into equal sizes. So the first one we divided into 6 pieces, and we have 3/6. And the next one we also divide into 6 pieces, and we have 2/6. If I add those together, so that would be 5/6. Is that the only way to do that? Is that the only common denominator? Could I make a common denominator that's 1,000? No. 3 does not go into 1,000. So, yeah, what if I took this and times them both by 2/2? Is 6/12 plus 4/12 going to give me the same answer? Yeah, you would get 10/12. But that was an incredible waste of my time, right? So when we get to rational functions, you can make your life very, very difficult by picking the wrong denominator. Okay? So let's look at one that's a little more complicated. Let's do 5/12 plus 4/9. Here's one way to get a common denominator. I'm just going to times this one by 9 over 9, and I'm going to times this one by 12 over 12. Would that work? Is it a good idea? Definitely not. Okay, what is the common denominator going to be? Well, 108 would work, but that's not the one we want. So some of you did that in your head, and the rest of you are wondering how on earth did they figure that out. So here's one way to do this. We pick the small denominator, which is 9, and we go through the multiples of 9 until we hit one that 12 also goes into. So we could say 9, no, that doesn't work. How about 18? That doesn't work. How about 27? No. 36? Yes. That's way too slow. There's got to be an easier way. So, does anybody remember the method to calculate the least common multiple? Okay, the least common multiple has two attributes. It must have all factors of the two numbers. Okay, so it has to have factors that involve all of them, and it must have, how do I want to put this? It needs to have the greatest number of the greatest multiplicity. That's probably the way to do it. Of each factor. So my common denominator will have all of the factors that the original two have, and it will also have the greatest multiplicity that shows up on either side. So here's what I mean. 12 is 2 times 2 times 3, and 9 is 3 times 3. So I know that my common denominator is going to be made up of 2's and 3's. Okay? So the way you pick how many is you look at the greatest multiplicity. What is the greatest multiplicity of 2's? So this has a pair of 2's, and 9 doesn't have any. So my common denominator would be 2 times 2. What is my greatest multiplicity of 3's? 3's, which is 36. Now, hang on, you'll get better at this. So now I look and I say, if I'm going to create a common denominator, what is this denominator missing? It has a 2, and it has a 3, but it's lacking another 3. Okay, what is this denominator missing? It's missing a 2, which would be 4, and I get 15 36ths plus 16 36, which gives me 31 over 36. Okay, now we're going to do it this way. I know it's going to be a pain for you, but this exercise will make rational expressions so much easier. If you, well, you probably won't be able to do rational expressions if you don't understand this. So let's make it a little more complicated, because I like that. Now, something like this is going to be hard to find the least common multiple if you do 48 plus 48 plus 48. You don't even know your multiples of 72, right? So let's factor 72. 8 and 9. 2 times 2 times 2 times 3 times 3. Everybody got that? 48 is 6 and 8. 3 and 2 times 2 times 2 times 2. So what is my common denominator going to look like? 2 to the... Right, you pick the greatest multiplicity. Because your common denominator has to have everything that's in both sets. So if I said the common denominator had 2 to the third, then I would be lacking a 2 on this side. So 2 to the fourth times 3 squared. Now, what if I looked at it the other way? What if I picked the least multiplicity? So the least multiplicity would be 2 to the third times 3, which happens to be 8 times 3 is 24, whereas 2 to the fourth is 16, 16 times 9, 144. If I pick the least multiplicity, that is the greatest common factor. If I pick the biggest multiplicity, that's the least common multiple. Right? 24 is the biggest number that goes into 72 and 48. 144 is the smallest number that 72 and 48 go into. Does that make sense? So you have to pick, if you're finding least common multiple, you do the greatest multiplicity. The least multiplicity would be the greatest common factor. Okay? So, yeah. So, what am I going to times this one by? That's missing a 2. So 22 over 144 minus, what is this one missing? It has 2 to the fourth and it has a 3, so it needs 3 over 3. So that would be minus 75 over 144, which is negative 53 over 144. And 53 is prime, so that doesn't simplify. Okay, let's try another one. Let's do 7/30 plus... Hold on, I gotta do this in my head. Um, 80 plus 9/84. So to find the least common multiple, I factor. This is 2 times 3 times 5. And this is 2 times 2 times 3 times 7. Okay? So, what is my greatest common factor going to contain? 2 times 2. So, from here, and then a 3, and a 5, and a 7. Does everybody get that? Making goat noises over there. Oh, all right. So, what is this side missing? A 2 and a 7. What is this side missing? It has a pair of 2s, a 3, a 7. It just needs a 5. So 49 times 2 is 98/30. Wait, not 30ths. What is this? 2 times 2 times 3 times 5 times 7 is 420th. Yeah, you have to... It's got to have a pair of 2s. Shem, are you confused? You pick the greatest multiplicity. So there's 1 2 here and a pair of 2s there, so we pick the pair. There's 1 3. Oh, no, I meant... No, I was multiplying this. Sorry. We were looking at two different things. And then, so 98 and 45 makes 143 over 420. Is it possible that this would simplify? Could it ever simplify? Yeah, it could. It, for instance, let's look at um, so let's look at 1/6 plus 1/12. So this is 2 times 3, and this is 2 times 2 times 3. So my common denominator is going to be 2 times 2 times 3, which is 12. So this one needs a 2. So this would be 3 over 12. Right, you have to match this denominator and this denominator. Right, well, does 3 over 12 simplify? Yeah, it's 1/4. So it can happen. After you add, you could have something that simplifies. Well, what if you had 3 fractions instead of 2? So what about 3/10 minus 4 15ths plus 6/9? How do we pick a common denominator? So this is 2 times 5, 3 times 5, and 3 times 3. So what would my common denominator have? Has a 2, a pair of 3's, and a 5. Everybody get that? So 2 times 9 times 5, 18 times 5, is that, what'd you say? 90? Okay. What is my first fraction missing? So it's missing a 3 squared, so 9. What's my second fraction missing? A 2 and a 3, so a 6. And what is my last one missing? A 2 and a 5, so it's a 10. So I end up with 27 minus 24 plus 60. That would be 63 over 90, right? Does 63 over 90 simplify? They're both divisible by 3. So that would be 21 over 30. Does that simplify? Yes. 3 again, 7/10. That would be your answer. No, you got to do them the right way. Okay, well, what if I accidentally put another 2 there? Is that going to give me the wrong answer? Well, so I would have to put a 2 here, and a 2 here, and a 2 there. So it would be 54 minus 48 plus 120. So 54 minus 48 plus 120 equals 126. And now it would be over 180. Is that going to equal 7/10? It should, but is it a good idea to put in extra factors? If Jason wants to. So when we get to rational expressions, you need to understand how to make this as small as possible. Because it will always work if you put in extra factors. But by putting in extra factors, you're going to end up with equations that are way too big. Okay? All right. Go. Go.